Identifying major energy-saving opportunities. An effective energy audit is a systematic approach to identifying and evaluating energy consumption and potential efficiency improvements in a facility. By focusing on large equipment and major systems, organizations can often achieve the most significant energy and cost savings. Starting with large equipment, a strategic approach. 1. Boiler systems. Boilers are typically one of the most energy-intensive systems in a facility. Boiler key inspection points. Age and efficiency. Assess the boiler's age and its current efficiency rating. Insulation. Check for proper insulation on boiler surfaces and steam lines. Combustion efficiency. Measure and evaluate combustion efficiency. Operating conditions. Review operating temperatures, pressures, and load conditions. Potential savings opportunities. Upgrade to high-efficiency condensing boilers. Implement advanced combustion controls. Improve insulation and reduce heat loss, and optimize boiler sequencing and staging. 2. Chillers and cooling systems. Cooling systems can account for a substantial portion of a facility's energy consumption. Start by performing a comprehensive evaluation. Chiller performance. Assess current coefficient of performance, COP. Refrigerant condition. Check refrigerant levels and potential leaks. Heat exchanger efficiency. Evaluate heat exchanger cleanliness and performance. Cooling tower operation. Inspect cooling tower efficiency and water treatment. Use these energy-saving strategies. Replace old chillers with variable speed, high-efficiency models. Implement free cooling/economizer cycles. Optimize cooling tower operation. Use thermal energy storage systems. 3. Air handling units, AHUs. Air handling units are critical in maintaining indoor air quality and comfort while consuming significant energy. Detailed assessment. Motor efficiency. Evaluate motor age and efficiency. Fan performance. Check fan wheel condition and airflow efficiency. Filter status. Assess filter cleanliness and pressure drop. Ductwork integrity. Inspect for air leaks and proper insulation. Recommended improvements. Upgrade to high-efficiency motors and variable frequency drives, VFDs. Implement demand-controlled ventilation. Use advanced filtration with lower pressure drop, and seal and insulate ductwork. Audit methodology. Measurement and verification. Use calibrated measurement tools. Conduct spot measurements and implement long-term monitoring, and compare current performance against manufacturer specifications and industry benchmarks. Use thorough data collection techniques. Gather historical energy consumption data. Document equipment specifications. Record current operating parameters. Implement detailed reporting. Quantify potential energy savings, and provide cost-benefit analysis for proposed upgrades. Prioritize recommendations based on estimated energy savings, implementation cost, payback period, and operational impact. Conclusion. A systematic approach to auditing large equipment provides the most substantial opportunities for energy efficiency improvements. By focusing on boilers, chillers, and air handling units, organizations can typically achieve significant energy and cost reductions. 1. Develop a comprehensive energy management plan. 2. Implement recommended upgrades. 3. Establish ongoing monitoring and maintenance protocols, and 4. Consider professional energy engineering consultation for complex facilities.